Most of the next session. And the next session here at the Industrial Vision Days is going about hyperspectral imaging. So we will have 3 presentations about latest sensor technologies which enables the acquisition of image information from UV to vis over to SWIR wavelength ranges. And we will immediately start with the program, and our first speaker is Mike Faulkner from Photonfocus, who will give us a talk about their high-speed, low-noise SWIR cameras, that means short-wave infrared cameras, for challenging traffic applications. So, Mike, please come in front. The stage is yours.
Yeah. To change the slides?
Just a big green.
Perfect. Hello, everyone. Thank you very much for joining our presentation today. As I was introduced, we'll be talking about high-speed, low-noise SWIR cameras for challenging traffic applications. I will also go into some non-traffic applications. Presentation will be split into 6 sections. As you can see here, a little bit about us, a little bit of our product overview, what is shortwave infrared, SWIR applications, SWIR other applications, and then what we offer as state-of-the-art cameras for SWIR technology. So, a little bit about Photonfocus. We were founded in Switzerland 20 years ago. We've been known as a pioneer in high-performance imaging since then. Most people would say everybody calls themselves a pioneer. We can actually back it up with reality. 20 years ago, our founder claimed that CMOS sensors could be better, faster than CCD sensors. At the time, nobody thought it was true, but as we know now, nobody, or almost nobody, other than for scientific applications, use CCD cameras. Over the last 20 years, we've won multiple awards, and we have actually made our own sensors for the last 20 years, which I will talk about in a following slide. 2019, we were acquired by Vision, which some of you may know is a very large world-leading innovator in machine vision systems for automotive, robotics, glass, solar. In 2020, Vision was acquired by a Swedish multinational industrial group called Atlas Copco, which was founded many years ago in 1873. We are the center for camera excellence within the whole Atlas Copco group, so we can apply our camera knowledge from the last 20 years across more than machine vision, but across industrial applications and tools as well. So, quickly over product overview. Our main product lines are 2D cameras for visible, UV, SWIR, and hyperspectral. We have cameras for 3D applications in the visible and in the ultraviolet. We also have modular embedded systems, and as I mentioned earlier, our own CMOS sensors. What we're known for, as I mentioned earlier, was making our own sensors. The sensors actually offer very high quantum well efficiency. So as you can see by the second point at the bottom, our sensors offer 100 kilo electron sensitivity, while even the modern day Sony sensors offer 1/3 of that. One of the big applications for us was the high dynamic range in real time, which is a technology we call Linlog, which was patented many years ago. We're also known for our very flexible modular camera architecture. That means that you can buy a camera from us with an enclosure, you can buy a camera from us with only the board level. If you happen to need a different sensor, more power or less processing power, or a different interface, we can accommodate pretty much any kind of custom requirement that you may need. Now let's get on to the subject at hand, shortwave infrared. Shortwave infrared is basically the spectral range beyond 750 nanometers. And it extends all the way up to nearly 14,000 nanometers, or what some people call 14 micron. At each step, there's a different term for that range of spectral infrared. So starting with near infrared, which is just off of the red visible range, then shortwave infrared, which is what we offer as cameras, medium infrared, and as well as long wave infrared. Now, the big characteristics of SWIR, depending on the wavelength, of course, but in SWIR applications, it is not silicon-based sensors, but actually something called InGaAs, which is indium gallium arsenide. And that makes the sensor more sensitive beyond the visible. One of the problems we've had over years has been that SWIR optics have been very expensive, and over the last few years, SWIR optics have become a lot more affordable, thus making the application a lot more usable and accessible to many more applications. You could use, if you're stuck and you don't have, you receive the camera but you don't receive the optics, you could use visible optics. The problem is that since you're in a different spectral band, there will be an offset, so the image will never be as contrasty or as precise or as hard lines as you'd expect. So you do actually need to buy SWIR lenses for this band. One thing that's very cool is that colors that would appear nearly identical in visible light actually are easily differentiated in most cases using SWIR. Now, some of the advantages is actually seeing in the invisible. I know that sounds a bit odd, but you can actually see in the invisible with SWIR. This means that we don't need dedicated light. You can use a SWIR camera by moonlight. You can use a SWIR camera by street light. Or you can use dedicated SWIR LED or any other kind of lighting technology to illuminate the subject. Speeds have also increased a lot. And many years ago, when SWIR was only available on analog, you were limited to 15 to 30 frames per second. Now we can achieve easily 300, 350, and the speeds are actually still rising. What is also nice is that SWIR does not require active cooling of any sort. So if you need to use a SWIR camera in an industrial application, having active cooling can actually cause deterioration in reliability of the camera. This way, it is cooled by a Peltier tech cooler inside the camera, which is fully passive, and there's no external cooling mechanism involved. One thing that's also nice is that SWIR actually offers low noise images. Although the images are still a bit grainy, they're actually a lot cleaner than you'd expect given the little bit of light that you actually have to work with. Also, one handy little tip for software is that the temperature can be controlled by GenyCam interface standard. So if you need to monitor the temperature of the camera, you can actually get a readout through GenyCam parameters. Here's a classic use of SWIR, which you're looking at is an offshore oil rig. The top left image in a bit blue is a visible camera. As you can see, you can barely see the outline of the oil rig, and the foliage in front nearest to the camera is very dark. Although it should be green, there's not enough light to differentiate the color. When you use a SWIR camera, you can actually see very clearly the light at the end of the oil rig. And if you look at the bottom, the foliage, the greenery, the trees, the plants actually change color. They're no longer black or gray. They become actually almost illuminated by themselves. Now, SWIR for traffic applications have a slightly different requirement than industrial applications. Traffic applications, you need to handle all kinds of external physical lighting conditions. You don't have a perfect light. You need to have light, whatever that can be used for the application, whatever's in the environment. So SWIR is not dependent on the lighting conditions. So you can use it in morning, afternoon, nighttime, cloudy. Also, it is not impaired by fog or dense rain or dense environmental conditions. Because of the application being traffic, you can't be running at 15 or 30 frames per second. You actually need to run at much faster speeds to be able to stop the motion of the vehicles that you're trying to see or of the surface you're trying to see. And because you need a high level of detail, although SWIR isn't into the megapixel range, and there's a very specific reason because there's no range, no commercially available high megapixel SWIR cameras, you need to make the best out of the image quality. So we need to have a very, as much as possible, low noise image to acquire and work with. Some of the applications for traffic with SWIR is surface recognition. So you could detect, because of the way SWIR works, the way it'll penetrate or reflect off of the surface, you can actually detect icy conditions. You can actually detect contaminated road surfaces. Also interesting to use for automated license plate reading systems. because you can use one camera for all lighting conditions. You don't need to have a color and a monochrome, so a color by day and a monochrome by lower light. You can actually have one camera to be more sensitive across the whole spectral range. It is also needed to be fast and reliable because you are trying to catch cars going much too fast. And again, independent from weather and lighting. Also, SWIR started off mostly as a surveillance technology. So if you need to do people detection, you need to do animal detection. There has been applications where they had, it's a remote location. They need to see if there's anybody coming in the middle of the night. And in most cases, it was less false alarms because of people and more false alarms because of animals that were actually walking through their protected environment. Now, let's talk in general a bit about SWIR applications in general. One place that is very interesting is for quality control in the semiconductor industry. The image you're seeing there, the gray parts that you see on the sensor surfaces, that's delamination. If you were using a visible camera, you may not pick all of that up. Because at SWIR, it will actually show up quite clearly. Next, in agriculture and recycling, you can classify materials much easier. So clay mineral sorting, recognition of raw materials, raw resources. One that's a bit unusual is paint penetration and material fatigue. So used in applications where manufacture of home appliances for your fridge or stove, etc. You can do a bit of a surface penetration fatigue test. Also used in automotive painting processes and shipping containers, as you see in this picture. This picture is not photoshopped. This is actually a picture taken from a visible camera on the left and a SWIR camera on the right. This is not X-ray. This is actually SWIR. The surface of the container, whatever is touching it from the liquid on the inside, actually reacts differently to the SWIR wavelength. Another one that's interesting is for the chemical and medical industry. The image on the left are all liquids that are all appear white to the eye. So in this case, acetone, ethanol, vodka, oil, propanol, and water. But when done to SWIR, they actually have different visual signatures in the SWIR spectral range. One that's pretty classic is agricultural food inspection. So you can actually see the decomposition happening below the surface before the decomposition affects the surface of the fruit. One that I like a lot is sugar versus salt sorting. This is a bit of a, this is not an actual application, but it's actually a very good example of how the visible tricks your eye versus the SWIR that can't be tricked. So this is interesting for sugar and salt if you ever get into that kind of a situation, as well as a real-world application of potatoes versus golf ball sorting, where there was a potato producer who had a field next to a golf course, and those who weren't as good, the golf balls would go sideways into the potato field, would be crushed up as they were picked up, and once you showed it to the visible camera in the production line, a broken up potato and a broken up golf ball looked the same. So if you're planning on making French fries, well then the chance of your machine getting damaged down the production line becomes a lot more expensive and dangerous. One big application is recycling, where you can recycle the plastics, garbage minerals. I've heard that in the European Union there's a new regulation that you have to separate recycled concrete from gypsum. So this in the SWIR world actually appears cleanly and clearly separated materials as they're mixed. Now let's talk about some of the state-of-the-art in SWIR. What you see here is one of our new cameras that not only works in SWIR, as you can see from the top plateau down to the bottom right, it actually also sees into the visible range down to about 400 nanometers. This becomes interesting for applications where you may have a crossover, which you need to do visible and non-visible at the same time, split up the image into different processing buffers to do an image processing algorithm on. Our camera is 640 by 512 pixels at 350 frames per second in 12-bit. And if required, we can always shrink the image size down and get even more speed out of the camera. So a bit of an oxymoron is the phrase "see the invisible," because you really can't see the invisible unless you have non-visible spectral technologies like SWIR sensors. Now, with the new level of technology that we have, we can do traffic, industrial, manufacturing, food applications, basically everywhere, and basically some areas that we haven't even discovered yet, I'm sure. So we now have speed, we now have optics that are now affordable. Our cameras specifically are very small, they're very robust, they're very low power, and we use all the modern interface technologies like CameraLink, GigE, 10 GigE. Our cameras, again, as I mentioned in one of the earlier slides, we can also offer these cameras as OEM boards or as OEM customizations. If you need anything done specifically to it, that is also possible. One example would be where one of our clients liked the camera, but had a problem with their optics. Their optics, for whatever their design was, were offset. So we literally designed a new sensor board that had an offset sensor from the center of the camera. So the camera optics line up perfectly, and then the rest of the camera is moved to the right and then connects to their existing cabling infrastructure. And our cameras are industrialized C-mount robust connections with cooling that is not required to be external to the camera. The cooling is done internally to the camera. Here's a brief chart showing you a bit of our range. While you're reading this, one thing I'll point out is the pixel size. In this day and age of high megapixel cameras, most cameras have pixel sizes of 3, 4, 5, and below 2 sometimes micron pixel sizes. When you get into the SWIR, all the sensors that we make available are all very large at 15 to 30 microns. So I hope this was interesting to you. This is the end of my presentation. If you have any questions, please feel free.
Okay, thank you very much. The room is open up for questions, so please feel free to ask the expert in SWIR camera technologies and imaging.
No? Oh, good, we have
There
one.
is a question.
Cool.
Yeah, thanks for the interesting talk. Just a quick question on the size of the pixels and the resolution.
Mm-hmm.
What is your forecast for the next years regarding those two quantities?
Well, like in anything, the smaller the pixels, the more resolution you can fit on a given size wafer. There will likely be some new developments in terms of how the pixels become a bit more sensitive so that they can be shrunk without creating more noise. There are new sensors coming out that are actually starting to get into the megapixel range. The interesting part is that a lot of the limitations in SWIR have been limited by the US military of how they don't want the resolution to be high and they don't want the speed to be high. So there's a bit of a compromise that's done there. But with the new sensor technology coming, I'm guessing, I won't make any predictions, but I'm guessing it should improve.
Okay, so it's not a strict limitation of the InGaAs technology, but there's other reasons.
Yes. And usually in our machine vision business, as we all know, things get better at a very steady clip, very steady rate, except there. And for the longest time, we had available 180 by 160. That was low res. And then high res was 320 by 240. That was high res, which was usually fun because if you connected a 320 to 40 high res camera next to a SWIR camera, next to a visible camera at 640, 480 or higher, it was a very challenging topic to try and get things to match up. So I hope that answers your question.
Thank you. Yeah, it does.
Okay, thanks for the question. Thanks for the answer. Are there further questions? Okay, then I have a question.
Okay.
So pioneers in SWIR camera development like Photonfocus showed these nice applications. And from my personal point of view, there are maybe even more applications than in this actually in future. At least I'm expecting that. But when does the technology overcome this pricing limitation? And when do we get SWIR imaging in a broad range for everyone?
Well,
What are
as
the
I
limiting
answered
factors there?
the gentleman over there, part of this is technical and part of it is commercial. And in-gas is, it may be becoming less exotic, but it's been considered exotic for many years. And it has to, there may need to be some manufacturing process improvements to handle, to bring it to the next level. But yeah, timeline, I'm not sure. And then the commercial restraints may be a bigger stop than the technical restraints.
Okay, okay. Last question. Will InGaAs be the technology in future, even if it is now on a very major level? But are there other sensor technology which can extend SWIR and, for example, MVIR, so even longer wavelength ranges?
Well, as you get into the longer wavelength spectral ranges, the material also changes. So in SWIR, it's InGaAs. When you go to mid-wave, it may be a different type of sensor technology, and same thing with long wave. The mid-wave and long wave are available. They make some very interesting products with these sensors. The problem is that the sensor manufacturing costs are astronomically high. For what it costs you now for a SWIR camera, you could take the price, double it, and that would be the cost of your sensor. Not the camera, only the sensor. And although we've looked at this type of technology for even higher ranges of infrared, the problem is that will the market, other than scientific, accept those kinds of prices for a camera to be put in a plant in a industrialized environment? And remember that if you want to put a SWIR camera inside an enclosure, you also have to have an enclosure that has the appropriate glass or the appropriate film at the front to protect it from it. So you can't just put a SWIR camera inside of an enclosure with a glass. You just basically just stop, the image stops there. So.
Okay, okay. Thank you very much. Last question. Where's your booth?
We are in Hall 10 at G40.
Okay, so there you can see the applications and the technology. Thank you very much, Mike Faulkner.
Thank you.